Hi. So actually, instead of how to start, let's consider this how I start. And basically, this is going to be a talk on some techniques that I have found make me more effective at software delivery. So we're, already. Yeah, that'll do. So there's a joke that's been going around for 10 years or so that you can measure software delivery by what the fox per minute. But I actually think this is terrible. I mean, it's so bad in our industry that this is the humor we pass around for what our day is like. We shouldn't be measuring how often we're confused. We should be measuring how often we make decisions confidently. We should be measuring how often we deliver value to an end user. We should be measuring how comfortable we are, how confident we are that we are doing what we think is the correct thing to do. And most importantly, we should do it calmly, not frantically. So in the spirit of friendship, in the spirit of me having learned some really horrible lessons, and hopefully you won't have to, I'll give a couple of the things that I've found helpful or useful, either as a junior or as one of the experienced people on a team, or even as a lead coaching people throughout software delivery. So to start with, I think the why, the root of why we're doing something is always really, really important. Who here thinks they do agile delivery at work? Who thinks that sprints are important to agile? Who thinks that stand-ups are important to agile? Who thinks backlog refinement is important to agile? Who thinks planning is important to agile? Who's read the Agile Manifesto? So the Agile Manifesto, which is where Agile comes from, mentions none of these things. There are 4 very simple principles that are intended to make your life as a software engineer or anyone in a software delivery or a product delivery team, regardless of your role, calmer and more correct. So one of the hardest things in software is getting started, putting the first couple of keystrokes down to solving a problem, understanding why you're doing what you're doing. And the confusion around how to do it effectively makes it so much harder than it needs to be. So one of the things that we get told is focusing on agile outcomes. We probably all do a mishmash of agile, of Scrum, of Kanban, of Lean, of some mechanism of delivery. Some of us may be unlucky enough to do waterfall. But at the end of the day, the goal is delivering value to an end user somewhere. Now, in most of our teams, we've been, I won't say conned, but definitely led to believe that the best way to do this is to have a game of telephone from the customer to a person who is the domain expert, to a person who interprets what the domain expert thinks is important, to write something down, a ticket or a post-it note or something, to give it to a person who is the architect who's going to make the technical decisions for your team, to build a design document, to give it to you finally. By the time it reaches you, it reflects nothing to do with what the person who actually wants this feature, none of their desires, none of their requirements. And then we're expected somehow to make good decisions out of this and turn it into code. And this is a complete unlikely scenario that flowing this game of telephone that you'll end up with a good understanding of exactly what the customer is trying to do. So one of the things that we recommend, you can see in the manifesto, that we should be collaborating with customers, that we should be working with them to deliver these features. And part of the reason for that is you never have enough time. Depending on whether you're working in a startup, whether you're working in a consultancy, whether you're working in a big company, it doesn't really matter. Regardless of what you're doing, you won't ever have enough time to go through the entire journey, find out all the different ways you can be wrong, loop back to the beginning, find out new ways that you happen to be wrong, finally get it right and deliver it. So anything you can do that helps you cut down on those dead-end parts of your journey are good. The biggest one for me is talking directly to customers. As a lead, as a person who hires engineers, one of the biggest things that I'm looking for in the people that I'd like to work with are that they are product-focused or that they are user-focused. So it's not enough to just be comfortable with technology. It's not enough to be really, really good at any particular kind of delivery. You also have to care about why you're doing something. And you have to be able to engage with the user on the other side of it. And you've got to be comfortable actually talking to that user to understand why they care about the thing they're doing. Because a lot of the time you'll find they'll articulate that they have a problem, and it will turn out that there's a solution that you're comfortable with because you spend all day working in this product, in this code base, that they haven't thought of. They just know this is a very frustrating problem I have. They don't know how great it's going to be when you come along and solve it. So the more time you can spend getting in front of a user, the better. We've spoken to a user, we get given a story, we're comfortable that it's the right thing to be working on, it represents the most value for whatever we can think of. Now what? How many people here feel like they have a well-understood formal process for problem solving? This is what we do all day though, right? Every minute of the day that we're working, we're solving problems. We're dealing with issues. Someone gives us a task to complete. Whether it's find out why the server falls over every time someone puts in a string that is longer than 32 characters, to I want to build this feature. And a lot of the time, especially when I started, when I was first a junior, the way that I would solve problems is like what's up on the screen. I'd get given a problem, I'd start working on it, I'd bounce around trying to find the solution, and I would bounce off all of these different ideas. And eventually I would cobble something together and I would get it into a shape where I could put it up for a pull request. I'd give it to the team, and then I'd find out how wrong I was. And there were all these things that I didn't know or I didn't think about, or a lot of our code bases have a lot of really good decisions in them for a really good reason, and that information is stored in our teammates' heads, and I didn't know that. And the problem was, by the time you get to that pull request stage, you've spent a day, you've spent a week, you've spent however long working on this problem, and now you have to start again. Or now you have to undo a whole bunch of the stuff you did. So this isn't a fun place to be. It feels terrible when you get to that point. And if this sounds like you, or if this sounds like someone you work with, there are a couple of techniques that I've been using for the last few years that I find really, really useful for not ending up in that dead-end position of I was completely unsure of why I was doing this. I had no idea what I was doing, and now I have to go back and try it again. So my formal problem-solving strategy, and I use this on every problem that I solve. Write down the problem, all of the data, all of the metadata that you are comfortable that you know. Break the problem up into deliverable stages and graph it. Replace anything you're not sure about with a mock. So we call this black box testing in electrical engineering. In software, you replace it with a function that returns a value. And you just decide, this is the value that I'm going to want this thing to return when I can figure out how I'm going to write it. So I'm going to put a static function in place, and it's always going to return that value, and I'll come back to it when I know more. Solve the first stage that I'm confident about. And then keep recursing until there's nothing left to solve. Now, this is really useful if you're a junior, because it's very unlikely when you pick up work for the first time that you're really going to know how to solve something end to end. It's much more likely that you might be comfortable solving a piece of it or solving some unrelated pieces of it. But if you don't know how to get over that first hump of I don't know how to begin, you're going to have to wait for someone more experienced than you to have time available to come and help you. And that's very demoralizing. So the first big confidence boost that I got in engineering was recognizing that even if I didn't know how to solve the entire problem, if there were bits of it that I did know how to solve, I could start there. And I could send a message on Slack, I think it was HipChat back then, send a message on the chat program and say, I'm having trouble with this concept. Can someone, when they have time, come over and help me out with it? And in the meantime, I'm going on all this stuff and I'm comfortable and I don't, I'm not blocked, but it would be nice when someone has time to come and give me a hand. So we'll go through what that might look like with a tangible example from something that I've been working on for the last week or two. And it's, as a user, I would like to be able to define promotions for my shopping cart service so that I can drive business behaviors of my users to increase the size of their shopping cart so they pay me more money. This is a fairly classic e-commerce problem. Depending on the industry you've worked on, you probably have similar kinds of things. And it's deceptively complex. It's not as simple as, well, okay, you name the thing and it goes on and you're finished. But it's very easy to start working on it. And it's very easy to work on it for weeks and make no traction and find out after weeks you haven't delivered what you were hoping you would. So the very first thing I do, write down the problem I'm trying to solve, write down what I know about it, write down what I don't know about it. I use a template that I've worked in teams on for a while. We've called this process a design PR, a design pull request, similar to a code pull request. And the idea is that regardless of whether you're a junior, whether you're a senior, whether you're a lead, whether you're the CTO, it's useful to define a problem within the scope of what you know how to deliver, within the scope of what you don't yet know how to deliver. And as a junior, it might be really helpful. You write this out, and then you discuss it with someone more senior. As you are more experienced, maybe you don't need to discuss it immediately. Maybe you're comfortable just starting to burn it down, and you just keep the document up to date as you go through this process. If you're the head of the company, or if you're a lead, or if you're running a team, it might actually be really useful to take 1 or 2 people on your team through this journey with you, and use this as a passive mentoring opportunity to show them what problem solving looks like in the scope of something where you don't actually know the entire problem. So it's really tempting to pair program when you know that you know how to solve something. It's really tempting to pair program when you already, you're comfortable with the solution. But a more useful thing to try and show the people in our team who are coming up to speed with how we work is what we do when we don't actually know how to solve something yet. The ways in which we might research, or the ways in which we might try. So we've got this document, we've written down what we don't know, we've got the approach we'd like to take, and we've got the requirements. So the next thing we do is we graph out. These are the stages of delivery. These are the pieces in the program that I'm fairly comfortable I'm going to have to build. And shade in red the ones that you have no idea how to begin. Shade in yellow the ones that you're pretty sure you have an idea of, but you're going to have a little bit of time to really understand how to deliver it. And green is anything that you can just go on now. Once you've got that in place, you've got a pretty good formalism for unblocking yourself. So making sure that you are comfortable with the work you should be doing and how to start. And you know now the edges of the program that you should try and mock out and come back to later. So we'll talk about the actual example. There are 3 things that I'm not really sure how to do. I'm not really sure how to build a rules engine. I'm not really sure how to flatten the list of effects and turn them into something useful to update the cart. I'm pretty comfortable once I have that list of effects that I can apply them to a cart without too much trouble, but I'm not really sure how to update the order at the end of it. Now, if I didn't use this strategy, I'd start at the rules engine, because that's the tip of the spear. And I'd work and I'd work and I'd work, and I might get nowhere. And I'm not delivering value to the company, to the business, to my team. I'm making things harder for everyone. I can unblock myself by saying, well, I understand what the cart update looks like, and I can probably sketch out a pretty good API. So I'll do that. And once I've got that API well understood, maybe that'll reveal something about the edges as I go. So we start here and we just describe these functions. We actually put no data in them. There's no code, there's nothing in it. Really all we have is we have something that says, here is a rules engine. Please don't worry too much about what a rules engine means. We have, here's a way to get effects out of a rules engine. Oh, not sure yet. We have, here's how we apply effects. Here's how we take the promotions that we want to apply and update the cart with those promotions. And now we can update our validate cart method. So we already have this pre-existing validate method. And we can add a couple of new pieces of code to it. We can say that after we finished validating the cart, that they haven't tried to change the prices on one of our products when they're trying to buy it, or something sneaky with the form in the front end. If it's invalid, we return the fact that it's been validated, it's invalid, we don't want to apply any promotions to it. But if it's valid, we want to apply effects. And we can see here that apply effects hasn't been filled out yet. We don't actually know what it means. But because we're just writing this out effectively in pseudocode, we can just kind of process through it. The nice thing with JavaScript being a dynamically typed, very flexible language is that even if you have no data in your function, you can still mock them. You can still tell them to return something when you're writing unit tests. And you can actually develop your own understanding of what the system needs to give you for your feature to be successful before you've actually finished writing out how you're possibly going to get that. So the way I approach this problem is you have your unit testing process. You write up some unit tests that describe the behavior of the areas of the pipeline that you're comfortable with. You mock their dependencies to give you back some static value that you're comfortable describes the API you'd like to support. And then you set up your expectations. So in this case, we're basically saying, I have defined what I think the input to the apply effects function should be. And I've done that not by just giving it the value, but by saying the apply effects function is going to call getEffects. GetEffects is mocked to resolve with this data, regardless of what I define getEffects to do. It's always going to resolve with this data. And now I just write the test. I write the test as if that's what getEffects is going to do anyway. Don't have to worry about what my implementation of getEffects is going to look like yet. Write all the tests. I've now solved the bit that I was confident about. And we can see that now. We can basically say, okay, well, this is what the structure of apply effects is going to look like. I've decided that an effect is two fields. It has a type and a value. Based on the type, I know how to apply the value to the total of the cart, and that's what I do. But I haven't written the rules engine yet. I haven't figured out how to flatten the effects into a list I can apply or how to join them or anything like that. I haven't really had to solve the parts that I'm not comfortable with. But I've solved the bit that I knew. So what do now? I go back to the beginning of the problem-solving thing, and I take the next bit that I'm the most comfortable with, and I make that the total system I'm going to try and solve. And if I'm not sure about how to do it, I'll break that up into pieces I recognize and pieces I don't. And I'll continue to recurse exactly like that until either I have nothing left that I know how to do, and I need to go get help from someone to help me doing it, or until I've solved everything by breaking it up into smaller and smaller pieces, black boxing or mocking the parts that I'm not comfortable with, and solving the bits that I am. One of the other things that I think is really important is not just how are we solving problems, but how are we getting better at them? What are we doing to continue to improve the way that we do these things? And the core functionality for that for me is designing a code base in such a way that the decisions are obvious, that it's clear why we write code in this way, that it's clear where a particular decision is made, that it's clear how you might try and add a new solution into the same flavor as what's already in the code base. And because of the way that JavaScript works, the way that I like to do that is using nouns, using structures that are familiar, saying that there are certain shapes in the code base that have certain responsibilities, and that if you want to do something and it matches that responsibility, you have to define a shape that handles it for that use case. So most of the Express code bases that I've worked on kind of look like this. They just have a controller. The controller does a whole bunch of stuff. We don't really think about what the responsibility of a controller is. We hit the database. We serialize the object. We don't really apply any safety here that's shareable. We just kind of return stuff. And when we start, this might be fine. You know, if you're working really quickly to get out a solution and you're just really hitting it hard, that might be fine. But 6 months, a year, 2 years, 5 years down the road, when you come back to add a new feature to this, and you've added a new field on the user that it turns out you also don't want to give to the front end, and there's not an obvious place for you to look for where all the places you serialize a user and send it back to the front end are, and you're working in JavaScript, which doesn't have types or an ability to tell you where something is used, you're in for a lot of trouble. So if we're not adding TypeScript, although I love TypeScript and it's a great solution, and if you have the chance to use it, you should. But we're working on a dynamic code base. We don't have TypeScript. We don't have a lot of static analysis. What can we do to be kind to our future selves? So one of the things I like to do is I like to try and build pipelines of things. And I find that when you describe a HTTP flow as a pipeline, or really any problem as a pipeline, you get a really comfortable idea of what the steps you have to take are, what the nouns, what the things that are part of that set of steps are, and how those might reflect other nouns that you've used elsewhere in the code base. So in this case, we have an extractor. We say we don't know what the parameters that are going to be passed to the controller are. We don't want to just assume that they match exactly what we want, because then someone passes admin true to a user creator, and now suddenly the user they created is an admin of our system, which is what Rails used to do by default, and they added a whole bunch of safety around how to actually do that. We don't want to just arbitrarily hit the database. We want to have some stuff behind a function that can do checking behind the scenes for, should we be giving this user the ability to get this user? Should we be, how do we handle authorization? How do we handle authentication? But we don't have to handle that in every single controller. It's nicer to handle that in 1 or 2 places and reuse them. We're always going to try and validate that the result that we're sending back makes sense. And we're always going to want to not send the entire object that represents our domain model or represents our persistence object or represents some data in our system. We're always going to want to change the representation of that object to fit the use case. And this is an important concept, because if you always just send back exactly what's in your database, you find that what's in your database has to grow and grow and grow to cover every use case where you might want to use it. By splitting it out into the various ways that it might be used based on who is using it and who's asking for it, you can add a little bit more behavior without having to have a database model that handles every single use case in your code base. So the way that I tend to think about HTTP flows is pretty much this. You start with a user request into the system. We figure out the route that it should go to. We validate that the input is correct, whether that's the URL parameters, whether that's the query string, whether that's the body. We validate that the input is correct, and we validate that the person who is asking us to do this thing should be allowed to do it. We try and do that at the very edge to start with. If they're not authenticated, 401 or 404. If they're authenticated but they're not authorized, 401 or 404. Continue down that pathway with the things you can handle immediately. And then with every block after this, if you have extra requirements you might want to apply, you apply them, but you apply them in the place where they are meaningful. So you don't make your router know that every function inside there may care about whether a user is an admin or not. You don't make your router know whether or not it's valid to only add 1 day lead time to a product, but only on Sundays and only if it's the 3rd Sunday of the month. You make your particular functions, your particular services, care about the things they care about, and then you find a way to glue it all together. We gather data from whatever our persistence objects are. So we gather data from our database, maybe from our caching layer, maybe from an external service. But we do that in one particular place, and we try and only do that before we try and do data manipulation, so that it's very clear and very clean where we fetch data separate from where we deal with data. We perform some action for the system. Once we've performed the action, we return a result. We serialize that result and sanitize that result and make sure that it's safe to give back to the front end. We don't want to return someone's Stripe API key. We don't want to return the password for the user. We don't want to send back their credit card details. We want to be very careful about what we respond with because our system has a lot of information that's really valuable, but that's not the same as everyone should be able to see what the valuable information we have is. And at any point of this flow, something might go wrong. Now, one of the other canonical things that sometimes goes wrong in our systems is when something goes wrong, we report the entire error to the front end. We show the stack trace, we send the database error because we're not catching it in an appropriate place. So again, it's important to remember that you should have a very, very fine-grained control over what you're telling consumers of your API. And you can do that by having an error serializer, whether that's part of the route specifically, whether that's part of your entire router, but having one place that can determine, is this safe to report back to the outside world? How many people have seen either of these two books, heard of them, read them? They're definitely not the be-all and end-all. There are lots of really good sources and resources for delivering or designing high-quality software. These are two of the ones that I like. I like them because they give you patterns to follow that help you interpret the world that you're dealing with. You may not like them, but I encourage you to find something that helps you identify, this is a problem that I'm seeing, this is a problem that I'm solving, and here's a shape that helps me interpret that problem so that I don't have to invent an entirely new solution every time I'm faced with something I'm not 100% sure about. So the final thing that I want to cover is how are we improving? So we spoke about how we can be kind to ourselves in the future, the kind of things we can do to make our lives easier as we go forward. But how many people focus on self-improvement at work? Okay? I mean, everyone here is coming to a meetup in your own time, and while the beer and the pizza is nice, it's not really the reason you do it. And I think that should be commended. I think that's worth applauding because you're putting effort and energy in to delivering better. And whether you do that for yourself, whether you do that for your own sense of gratification, whether you do that because you want to learn more, be more effective, I think that drive and that effort is wonderful. But you should make sure that in your teams at work, whether you're the most junior person, whether you're the most senior person, that energy continues throughout the day at work and doesn't just get corralled into one or two small things and definitely doesn't get left to only happen in people's free time. So my wife is a huge fan of rugby union and I not so much. But I was sitting with her watching a documentary on the All Blacks rugby team. And this is probably the most overused metaphor or analogy in terms of working with teams ever because everyone goes to the All Blacks because they're so good. But something that jumped out at me was you watch them drilling, and these are the best players in the world at the sport that they play. And they drill the same simple things over and over again, day in, day out, every time they train. They pass the ball 1,000 times. And they've been passing the ball 1,000 times every day since they were 10. and they continue to do it. And part of that is that when you get really good at the fundamentals, you're able to compose those fundamentals into something more complex. If you're not comfortable with the fundamentals, you have a really hard time building up more structured or more complex composition. So there's a saying which is that slow is smooth is fast. I first heard this from an agile coach that was working with us on improving the way that we delivered. And the idea is that you don't try and get good at something at the speed that you'll need to actually deliver it. You get good at it as slowly as you have to be able to do it smoothly. You don't want to do things under pressure. You don't want to do things under stress because we don't want to work under stress. We don't want to work under pressure. We want to be able to deliver calmly. We want to be able to deliver smoothly. We want to be able to deliver happily. So we practice things at the speed that we need to be able to deliver them comfortably. And when we get really comfortable at doing them, we can speed them up. So one of the ways that I find works well for me, has worked well for teams that I've worked with, is the idea of working on simple code solutions that are solved in a vaguely similar way, usually by test-driven design. You can do them as a mob, which means you can get everyone in your team together and work through a solution together. You can do them individually and just make sure that you cut out half an hour of your day to do them with a team. There are lots of different websites that do them. The one that I've got on the screen here is a thing called Code Wars. There's another really good one which is called Exorcism, which is a great name. The idea is that you have a solution, a problem which is a small problem, which is probably a building block of some larger problem that you'll have to solve at work. You get comfortable solving these kind of problems. When you reach that kind of problem in your job, you've already solved it a couple of times in a much simpler, much calmer setting. You don't get worried about, well, I don't know how to do this. You think, well, that maps to that problem that I saw there that I already solved. Let me see if I can find a way to bridge that gap and be comfortable that that'll work for what I'm doing here. Another really nice idea is the concept of a brown bag lunch. We would run them either having someone nominate that they'd like to give a talk to the team about something that they've learned, something that they've done. The other nice idea is a book club, so you identify some resource that you think will be really useful for improving what you do. You get the people who are interested in also working through that together. You commit to a schedule, and then you come in and discuss what you've learned over whatever the period is. These things are really nice. I encourage you to get them as part of your daily work, not as part of your lunch, because your lunch should be for you not working. But the idea is that you should have something in your day, in your week, at work that is professional development, that you don't only have to come to meetups and have pizza and beer and learn new things. And then the final thing, I think the contrast maybe there is not so good, but always be measuring, regardless of what you're doing. So we work in teams, we work in software. Some of the things we can measure are really obvious. Some of the things we want to measure, maybe not so much. But always have a goal that you're working towards. Figure out a metric you can track, and then track it. Try things. If they work, continue doing them. If they don't work, try something else. But make sure that you're driving towards a goal. Finally, you're working in teams. We work as teams. Play as a team. Help each other. If you know more than someone else, make sure that you're there to mentor them. If you're someone who doesn't know as much yet, make sure that you're working towards being comfortable saying, I don't know, and make sure that when you say, I don't know, you follow up with, but this is what I've tried, this is what I think might be the way, can you help me out with the edges of what I'm not sure yet? And if you can get comfortable with that, the more that you come up front with saying, I don't know, the more likely you are to start recognizing, I don't know, but maybe I can try and solve that myself. Maybe I've heard something that sounds a bit similar to this. But having that trust atmosphere where you can be a little bit vulnerable and recognize that you don't know something and have people in your team help you out with that leads to everyone delivering more comfortably, more calmly, and having a higher delivery. So yeah, thank you.